Okay, ma'am. So now we are going to discuss about interrupt service routines and some other parts as a continuation to the last class. Okay. Yeah. So in the last class we have discussed what is meant by an interrupt, and we have just discussed that whenever an interrupt occurs, we will go to the interrupt service routine like that. Okay. So this is a definition. In this slide, I have given some definition of what is meant by interrupt service routine. Okay. So what is meant by a routine? Interrupt service routine. The routine executed in response to an interrupt. A routine is nothing but a small. It is a subprogram. A routine or subprogram both are same. What is a subprogram? Subprogram is a program which is written separately from the main program. Okay, a subprogram is a program. It is also a program. It also consists of some set of instructions, but it is not written in the main program. Okay, it is written separately from the main program. Okay, it has some name. For example, it might have some name like Mohan or Krishna or something. Okay, in a program, okay, along with the main program, there may be hundreds of subprograms. Okay, there is no limit for number of subprograms. Okay, you can write any number of subprograms along with the main program. There will be a many number of subprograms. Okay, every subprogram can have different names. No two subprograms should have same name. Okay, so a routine or subprogram both are same. So an interrupt service routine is a routine or a subprogram. It will execute. When it is going to execute? Whenever an interrupt occurs or whenever interrupt service request is called as interrupt service routine. That means whenever an interrupt occurs, okay, then a particular device needs to service that particular interrupt. It is called as interrupt service routine. Just like see, when if I have some bike, I need to give for servicing for every 3 to 4 months. Why I will give it to for servicing means, in order if there is any problem, they will rectify, and I will just tell them the problem of my uh, problems what I am facing with that particular bike, so that the particular persons they will rectify it. Okay, so here also the same thing. There is a subprogram or there is a routine which will execute only when a particular interrupt occurs in order to service that particular interrupt. That means if I have any bike, if I give it for servicing means, what is the main purpose of giving it for servicing? I have some issue with brakes or clutch, or I have some issue with my bike has some starting problem like that. I will just tell all those issues to that particular servicing person, so that he will service that. Servicing means here he will rectify that problem and make my bike as in good condition, so that I can use it without any problem. Here also, whenever an interrupt occurs, a particular service is there to handle that particular interrupt. That is called interrupt service routine, short form shortly called as ISR. This is the definition of an interrupt service routine. Okay, and whenever, for example, if the interrupt occurs in the 10th instruction, that's what they are telling. If the interrupt occurs in ith instruction, okay, then it will go to the interrupt service routine. The interrupt service routine will execute the instructions, and again it will come back to the I plus 1th instruction, but not to the ith instruction. That means whenever the interrupt occurs in 10th instruction, it will go to the interrupt service routine. Interrupt service routines is nothing but small part of a programs. They are written separately from the main program. And again, after executing this interrupt service routine, it will return to the I plus 1th instruction, but not on ith instruction. That means if the interrupt occurs in 10th instruction, it will return to the 11th instruction, but not on the 10th instruction. Is it clear? So that is the concept of this one. Okay, na? Okay. Okay. So here, this is one more diagrammatical representation. Okay. So same thing. Here, this is the main program. Along with this, actually, after this instruction, these are the sequence of instructions. Okay. But due to some reason, an interrupt occurred. So I have told you previously, there are many ways of occurring an interrupt. It may be either due to the software, that means while writing in the program itself, I use some instructions which can cause the interrupt, like int space 03h, into, okay, like that, so that the interrupt may occur. That is one of the reason. Okay, that may be one of the reason. Okay, And another reason is while due to the hardware devices the interrupt may occurs. That is second reason. Okay, so here whenever an interrupt occurs, it will go to that particular interrupt service routine. It is going and it is executing all the instructions that are present in that interrupt service routine. The last instruction will be RET or IRET. Whenever an interrupt occurs, it will be IRET. When the normal subprogram, it is RET. Okay, whenever that instruction occurs, that indicates that is the last instruction in that particular interrupt service routine. IRET is the last instruction in that interrupt service routine. Okay, whenever that IRET instruction occurs, then obviously my controller or my processor will again transfer to the main program, but it won't come to the ith instruction. Okay, it will come to the I+1 instruction and starts executing from there. Is it clear? So that is the concept of this one. Okay. Yeah. Next, we are going to discuss about interrupt hardware. How the interrupts can be caused by hardware. That is called interrupt hardware. See what before this is, though it may looks a different topic like that, there is nothing difference in this, or there is nothing difficulty in this particular concept. See here, whatever we are discussing with reference to a computer, PC, personal computer, whether it may be a laptop or your desktop. Okay, so we are discussing with reference to a computer. Okay, computer have different devices, input devices, output devices. Okay, so it has software components and hardware components. Generally, interrupt hardware means the interrupts that are occurred due to the hardware components. Okay, hardware components are nothing but IO devices. IO means input output devices. IO means input output devices. Input device means keyboard, mouse, and output device means monitor, printer, like that. Okay, so here we are having IO devices. So what they are trying to say is in most of the computers we are having many IO devices. Okay, so in most of the computers we are having many input output devices like keyboard, mouse, printer, joystick, what we'll call if you have any loudspeaker connection. Okay, all these things in every computer, mostly these things will be there. One keyboard, one mouse, printer, monitor is going to be connected externally to the CPU. Next speakers, like that. Okay, so here we are having a single interrupt request line. See, that's what I will discuss in the diagram. See, we are having one common line. This is called interrupt request line. Okay, and these are the various devices that are connected. That means this may be a interrupt line related to a keyboard. This may be for mouse. This may be for our printer or our monitor, like that. Okay, see here we are having only one processor, isn't it or not? In every computer we are going to have only one processor, and for along to that processor only we will interface our keyboard, our mouse, our monitor, our printer, our speaker. Okay, these are the devices that are connected externally to our particular processor. Okay, so here what is the thing that is going to happen means, how can we interface? See, every person, if every person have different tasks. That means keyboard needs to perform some task, mouse needs to perform some task. Similarly, printer is going to do some task, like that. Okay, in order to perform any task, they need the permission of the CPU. Without the prior permission of the CPU, they don't have any ability to perform any task. ఎన్ని డివైజెస్ మనకు కనెక్ట్ అయ్యి ఉన్నా అన్నీ కూడా CPU కనుసన్నలోనే నడుస్తాయి. CPU మాట జబదాటి ఎవ్వడు ఏ పని చేయడానికి కుదరదు. ఓకే, so though I write something, enter some text on the keyboard, that should be printed, which should be printed in our monitor. Before printing also, the CPU should give access. Then only whatever I entered in the keyboard, that particular thing is going to be displayed on your monitor. Okay, if the CPU is busy in some other task, sometimes we may observe some delay. When we type something, we cannot get that particular text to be present in our monitor, or it is going to be present in our monitor screen after a long delay, because the processor doesn't grant any permission to access this task because it may be busy in doing some other task. Okay, that means whatever the tasks that IO devices needs to perform, they cannot perform on independent basis. They need the permission of the CPU. Okay, for every computer we have only one CPU. There may be multiple number of input output devices. Okay, in some devices I may place a scanner extra. Okay, extra scanners, joysticks I may place extra. Okay, if I want I can use some different input output components combinations. Okay, but whatever how many components you may interface, there is only one processor. Okay, and a processor cannot handle all the tasks simultaneously. That means at a time, if our processor if our keyboard requests for some access, similarly our mouse asked for some access, and our printer asked for some access, like that, if multiple devices asked for access permission, then our processor cannot give them simultaneously. Okay, it can give only it can give access to only one person at a time, but not all of them simultaneously. అంటే మీనింగ్ ఏంటంటే అమ్మా, మనకి ఇక్కడ ప్రాసెసర్ కీబోర్డు ఇలాంటి ప్రాసెసర్ కి కీబోర్డు, మౌస్, జాయ్స్టిక్, స్పీకర్స్, ప్రింటర్, స్కానర్, మానిటర్ ఇవన్నీ కనెక్ట్ చేశాం కదా. ఇప్పుడు అందరికీ ఏ ఒక అవసరం ఉంటాయి. ఏ అవసరం తీర్చాలన్నా ప్రాసెసరే తీర్చాలి, మధ్యలో ఇంకెవడు ఉండడు. ఇక్కడ మన ప్రాబ్లం ఏంటంటే మన ప్రాసెసరే ఈ అవసరాలన్నీ తీర్చాలన్నాం, బానే ఉంది. కానీ ప్రాసెసర్ అనేవాడు ఎట్ ఏ టైం ఒక టాస్కే చేయగలడు. అంటే కీబోర్డ్ ఏదైనా టెక్స్ట్ ఇచ్చి ఎంటర్ చేయమని చెప్తే అంతవరకే చేయగలడు, ఏది మానిటర్ మీద ప్రింట్ చేయగలడు. లేదు ప్రింటర్ ఏమైనా ప్రింట్ ఇస్తే దాని వరకు ప్రింట్ చేయించగలడు. అంతేగాని అన్నిటినీ ప్యారలల్ గా చేయటం అనేది ప్రాసెసర్ వల్ల కాదు. ఓకేనా. నెక్స్ట్, ప్రాసెసర్ కి మనం రిక్వెస్ట్ చేసుకోవాలంటే ఎట్లాగా అంటే చూడమ్మా, హియర్ వీఆర్ హ్యావింగ్ మల్టిపుల్ నెంబర్ ఆఫ్ ఇంటరప్ట్ పిన్స్, INTR1, INTR2, INTR3, so on. These all are connected to a common line. These all are connected to a common line. This is called interrupt request line. This common line is called interrupt request line. Okay, so this multiple number of interrupts are connected to a common line, which is called as interrupt request line. Okay, so what is the main purpose of this interrupt request line? Means, see, for every device here, if I have written INTR1, consider this is a mouse. One second. Keyboard. Consider this is a mouse. Yeah. Consider this as some printer or something. Okay, so here there are multiple number of, so on means there may be some speakers, there may be some joystick, something like that. Okay, so monitor, like that. So these are the multiple number of devices. Okay, so for example, if the mouse needs to perform some task, that means I am clicking something like this. Okay, this means this is the task that is being performed by my mouse. I am using this mouse to enter that one. Now if I want to delete or something, you know what I am doing, I am clicking eraser. See, whenever I am clicking this eraser, this is the task that is being performed by using my mouse. Okay, so now whenever my mouse is operating, here there is a line now, mouse line, there is a interrupt line related to this mouse. Okay, initially all these lines are going to be in a open state. That means they are in the off state. Okay, whenever a particular thing happens, then this particular device is going to be closed. Whenever then particular device is going to be closed. That means whenever a mouse requests for an interrupt, then this particular INTRU TR2 line is going to be closed. It is going to be closed. Is it clear? So whenever it becomes closed, then what is the thing that is going to happen? Then the processor will execute that particular interrupt. Okay, remaining all are in the open state and only this is in the closed state. Whenever it becomes closed, then the processor will perform the task related to only this particular device. Is it clear? That is the thing that is going to happen. Okay. Yeah. So that's what they are going to discuss here. All devices are connected to a line via switch to the ground. That means if you observe in this previous figure, see, this will act as a switch. The main purpose of a switch is on and off operations, and every device is connected to the ground. Okay, if the switch is in the open state means like this. Okay, then there won't be any short circuit and the entire voltage will reach the voltage that is present at the VDD. The entire voltage will go to, travel from here to here. Okay, whenever a particular switch becomes closed, whenever a particular switch becomes closed, then only the particular voltage will pass to that particular switch and it will reach the ground. It will come like this, pass here and it will reach the ground. Okay, is it clear? So if the switch is closed, then only there will be a passing of data, the passing of voltage. In rest of the cases, every switch will show logic 0. Every switch will show logic 0. So interrupt hardware. So all the devices are connected to a line via switches to the ground. That means all the devices are connected via switch to the ground. Okay, that's what I have showed now. So if any device wants to request an interrupt, what it is going to do? It will close the switch. Okay, so whenever a switch is closed, then the voltage will pass through it. Okay, that's what I have told now. Whenever this particular device wants some interrupt, it wants some access of the CPU, it will close this particular switch. Okay, then the processor will come to know that there is a requirement of this one, or I need to access this particular request of this particular device, and it will go to it will access that particular request. Okay, now so that is the main concept of this one. Okay, that's what they have told. And enabling and disabling of the interrupts, enabling and disabling of the interrupts. So what is meant by enabling an interrupt and what is meant by disabling of an interrupt? See, if this is enabling is nothing but the thing or the task what we have discussed in the previous slide. If a particular device wants to access the processor, okay, it will ask the processor or it will raise an interrupt. Okay, that means if a particular mouse wants to perform some task, okay, so it cannot perform its task on its own. నేను ఇక్కడ ఏదో ఒకటి క్లిక్ చేస్తున్నానమ్మా, ఇది క్లిక్ చేస్తున్నా, ఇక్కడ ఇంటూ కొడుతుంటే ఇది పోవాలా, అది పోవాలి అంటే ఎట్లా పోయిద్ది? మౌస్ మీద అక్కడ క్లిక్ చేసినమ్మంటే పోదు. ఇట్ నీడ్స్ టు బి పర్మిటెడ్ బై ద సిపియు. ప్రాసెసర్ అనేది ఓకే చేసి అది పని చేయాలి అంతే. ఇది వరకు మనకి పైకి కనపడుతుంది మౌస్ చేసినట్టు. మౌస్ won't perform these tasks. It's just it will ask for an interrupt to the processor and it will do some task. Whenever the interrupt, whenever the processor is free, then only it will execute that particular task. Is it clear? So sometimes we may see whenever the processor is not working properly, then though you close some programs, they are not going to be closed at a time. These phenomena you can observe in the lab systems that are present in our college. Okay, due to some thing, okay, though you close though you click on shutdown, those systems don't shut down immediately. They will take some lot of time because the processor is not granting them permission, because you might have opened some 6 to 7 sites previously. They may not have been closed properly, so that the processor is working with them, so it don't grant the permission for that particular mouse to give to access its one. Okay, that means the processor permission is must in order to perform any task. Okay, now we are discussing about this concept called enabling and disabling the interrupts. Okay, so whenever we want to enable an interrupt, okay, so what is the thing that needs to be done? Means we are having some pins, external control pins, enable pins, like external controlled pins, like I will show you in the next slide. Here, see, IE means interrupt enable pin. IE means interrupt enable. If this particular pin becomes 1, we can enable an interrupt. If this particular pin becomes 0, we cannot enable the interrupt. We will just disable the interrupt. That means enabling and disabling of the interrupts can be done by using IE pin. IE means interrupt enable. If the pin becomes 1, we can enable the interrupt. If the pin becomes 0, we cannot enable the interrupt. We will just disable the interrupt. That is the purpose of interrupt enable pin. Okay. So that's what they have given in a matter. The facility provided in a computer must give the program complete control over the events that takes place during the program execution. Okay, the device causes the processor to suspend the execution of one program and starts execution. A fundamental facility found in all the computers is the ability to enable and disable such interrupts as desired. That's what they have told. It is a enabling and disabling the interrupts is the fundamental facility that needs to be provided in every processor. That means ఏదైనా ప్రాసెసర్ లో ఆ ప్రాసెసర్ తనకు నచ్చిన ఇంటరప్ట్స్ ఎనేబుల్ చేసుకోవడం కానీ డిసేబుల్ చేసుకోవడం కానీ చేసే మినిమం ఫెసిలిటీ ఉండాలి. సింప్లీ టు సే, ఇది ఇఫ్ ఐఎమ్ వర్కింగ్ ఇన్ దిస్ కాలేజ్, ఓకే, మన కాలేజ్ కి డైరెక్టర్ సార్ ఉన్నారు. హీ హాస్ ఫుల్ అథారిటీ వెదర్ టు రిక్రూట్ ఎనీ స్టాఫ్ ఆర్ టు రిమూవ్ ఎనీ స్టాఫ్. ఆయనకి ఎవరైనా వర్క్ చేయలేదని డౌట్ వచ్చింది అనుకో, రిమూవ్ చేసేస్తారు. లేదు బయట ఎక్కడైనా వేరే కాలేజ్ లో మంచి వర్తఫుల్ క్యాండిడేట్ ఉన్నాడు అనుకుంటే ఆయన పిలిపించి మాట్లాడి రిక్రూట్ చేసుకోవచ్చు. ఓకే, that means he can enable and he can disable. Enable means recruiting, disable means removing. Okay, here also our computer should have that facility either to enable the interrupt or disable the interrupt based on its requirement. తన రిక్వైర్మెంట్ కి తగ్గట్టుగా ఇంటరప్ట్స్ ని ఎనేబుల్ చేసుకోవడం కానీ డిసేబుల్ చేసుకోవడం కానీ చేయడానికి ఉండాలా. సో if you observe carefully, there are many situations where processor should ignore the interrupt request, and interrupt request from the printer should be accepted only if there are output lines to be printed. After printing, interrupt should be disabled. So here they have given an example. See, sometimes though we may give interrupt, that means though the interrupt may be raised, our processor may take it light. Okay, what does it mean? Means see, if the student, for example, think that it is not an online class, and for example consider that the offline class are started. Okay, so while a particular faculty is teaching something, there may different students may interrupt the class due to so many reasons. That someone may tell that they need to go to the washroom. Some may tell that they need to pay the fee, exam fee, supply fee, something like that. Some people may tell that they need to go and consult our HOD sir for some reason. Some may tell that they need to go to the singing competitions or something, whatever, if any program is running on, so we need to attend that particular program, like that some may tell, isn't it or not? So the faculty may not grant the permission to each and every person who is raising an interrupt. That means if there is any personal problems, the sir will send, sir or madam, whoever it may be, okay, they will send to that washrooms or something. It is not an issue. Okay, and next case, if they ask, there is a problem of paying the examination fee, that particular person, if he is the particular staff member, if he is teaching some lesson very, what you will call, in a serious manner, okay, then he or she may not allow you to leave the class, because they are telling with some serious effects. Okay, and the class is going on smoothly. They don't like these kind of interrupts, because if they send you, obviously another 4 to 5 members or 5 to 10 members, they also will raise the same interrupt and they will leave out. Okay, so if the class is running in a serious manner or what you call smooth manner, so they won't, the particular he or she don't allow you. That means, okay, and if there is any singing competition that is happening, like that, someone if raise the thing, they will tell, okay, after my class you can leave, like that the particular faculty member can suggest you. That means here what is the main thing you need to understand is, there may be multiple number of interrupts from multiple number of devices. Okay, but it is not compulsory that the processor should execute all of them. Okay, it may ignore some interrupts. it may ignore some interrupts based on their priority. Priority means preference. That means, see here they have given one example. See, I have given some print option. I have some Word document, that means some syllabus of GATE or something which I am preparing, and I have just clicked on that particular syllabus Word document, and I have gone to, and I have just selected the print option, and I don't have any printer. Or if I have printer, my printer switch is not turned on, it is in off state. Okay, at this time, can it give printout? Is it possible to give printout? No, because first case I don't have any printer, that is one reason. Second case, though I have a printer, it is not turned on, that is it is in turned off. So can I give printout at that particular instant? Is it possible? No. So here also the same thing is going to happen. Though we may have multiple number of interrupts, okay, though we have multiple number of interrupts, our processor is not going to execute all of them. It is not compulsory by our processor to execute all of them. It will execute only a few and rest and leave it, depending upon their priority. Okay, that's what they have given, and they have given an example of printer. I have given some print option. I have selected print option, and I don't have any printer. So is it possible now? No. That's what they have mentioned here. Okay, so these are some of the things we need to know. So a simple way to provide instructions such as interrupt enable and interrupt disable that performs these functions. So we have these functions called interrupt enable and interrupt disable. So the first possibility is to have a processor hardware ignoring the interrupt request line until the execution of the first interrupt of the interrupt service routine has been completed. We have interrupt enable and okay. Here they are just talking about what is meant by interrupt enable and interrupt disable. Okay, why we will use this interrupt enable pin? See, whenever the interrupt enable pin is 1, that means the processor is busy in performing some interrupt. Here the main problem will occur because, see, I have mouse, I have keyboard, I have printer, I have what you call speakers, and I have monitor also. So that means I have multiple number of devices. Okay, these multiple number of devices, there is a chance that more than one device can request the processor to do their work simultaneously. ఇప్పుడు నా దగ్గర మల్టిపుల్ నెంబర్ ఆఫ్ డివైస్ ఉన్నాయి కదా, కీబోర్డ్, మౌస్, ఇలాంటి రకరకాల డివైస్, మానిటర్, ప్రింటర్, స్కానర్, ఇలాంటివి. మనకి ఇక్కడ ఏంటంటే ప్రాసెసర్ ఒకటే. దేర్ మే బి ఏ ఛాన్స్ దట్ more than 2 devices or more than 1 device may ask for an interrupt. That means ఒకేసారి నా పని చేసి పెట్టమంటే నా పని చేయమని ఎట్ ఏ టైం 2 అంతకన్నా ఎక్కువ డివైస్ అడగడానికి ఎక్కువ పాసిబిలిటీస్ ఉన్నాయిగా. ఓకే, మరి అలాంటప్పుడు మనకి ప్రాసెసర్ ప్రాబ్లమేగా, బికాస్ వీ హ్యావ్ ఓన్లీ వన్ ప్రాసెసర్, ఇట్ కెన్ హ్యాండిల్ ఓన్లీ వన్ టాస్క్ ఎట్ ఏ టైం. సో అట్ ద టైమ్, so what it will do means, whenever our processor is executing some task, okay, it will make IE interrupt enable pin as 1, interrupt enable pin as 1. Okay, this particular pin will be 1 until the particular interrupt is going to be executed completely. That's what they have mentioned here, is to have a processor hardware ignoring the interrupt request line until the execution of first instruction of the interrupt service routine has been completed. We have interrupt enable and disable at the beginning and ending of the instructions. Okay, so interrupt enable is present at the starting of an instruction. Okay, interrupt enable pin becomes 1 means that the processor is executing some instruction so that another devices should not disturb the processor until interrupt enable pin becomes 0. Okay, whenever interrupt disable pin becomes 1, okay, then only the new interrupt can ask for the permission. Okay, until that particular time it cannot ask the permission. Is it clear to you? Okay, నాకు ఇంటరప్ట్ ఎనేబుల్ పిన్ 1 అయింది అంటే మన డివైస్ పనిలో, మన ప్రాసెసర్ వేరే పనిలో ఉంది అని అర్థం. వేరే వాళ్ళు వచ్చి రిక్వెస్ట్ చేసుకోవడానికి లేదు. ఎప్పుడు దాకా రిక్వెస్ట్ చేయకూడదు అంటే ఆ ఇంటరప్ట్ ఎనేబుల్ పిన్ అనేది ఇంటరప్ట్ 0 అయ్యిందాక. ఓకే, ఇంటరప్ట్ ఎనేబుల్ పిన్ 0 అయ్యిద్ది అంటే ఇంటరప్ట్ డిజేబుల్ పిన్ 1 అయ్యిద్ది. ఓకే, సో దెన్ ఓన్లీ అనదర్ డివైస్ కెన్ ఆస్క్ ద రిక్వెస్ట్. ఓకే, So that is about interrupt enable pin. Whenever it becomes 1, that means the processor is executing some instruction. Is it clear? Okay. So we'll discuss the next rest of the topics in the next class. Okay.